Hello. Welcome back to this Linux crash course. After we've learned what the file system looks like, I guess it's high time to start talking about files themselves. What they are, how they behave, that's everything we're gonna cover today. But first, let's refresh what do we know by now. In the episode 0, we learned what is Linux. In the first one, we installed it on our virtual machine. And the third one, well actually the second one, by enumeration, we learned everything about file system. What does it look like, how it works, and how to navigate through it. Now let's jump to files, so the actual things we store in the file system. But file system can store not only files, there are also other types of objects, I like to call them. This here means the result in ls command. You've witnessed that before. If there is nothing, so this dash, it means this is a file. D stands for directory and L for symbolic link. To keep it short, it's just a file that's linking to another file in the file system. Kinda cool. Also, what we learned before are the privileges. For a quick refresh, first, the orange one is the object type, which I told you before. Then are the privileges for the owner. Next are privileges for the group, and the rest is for the others. Also, what these different characters mean R stands for read privilege, W write privileges, and X execute privilege. I talked about, more about it before, so I highly recommend check it out all the previous videos. But now let's expand this letter because these aren't only the permissions that are there. There are also a couple of special permissions. There can be this S in place of an X for owner, for group, and this weird T here. First, we have suid, which is special user privilege. This means that whenever we execute the file, it's going to run as if the owner ran it. So for example, if we have a Chrome binary, and we would run it, add this suid bit to it, then even though we would run it as Alice, the file, if it was in Bob's and Bob was the owner of the binary, it would say, hey, Bob is running this device. The same goes for the group privileges, which is right here. And this is just the same thing as suid, but for the groups, so running it as that group owner. And sticky bit is something a bit different because it technically makes nothing, but it makes the file immutable, which means you just can't delete it. You need to get rid of this privilege first to be able to delete it. But these privileges can be changed. To use it, to change them, we're gonna use chmod command, which stands for change mod. Yeah, it consists of three parts. First, the command itself, as you see here. Then we have permissions. So, set of permissions, and what do we want to apply them to? Permissions can be written in two ways. First is the symbolic way, which is who, what, which. We're gonna cover in a way. And the second one is the numeric way, by using three numbers. Let's start with the symbolic one. First thing is who do you want to give privileges to? Is it the owner, the owning group, others, or everyone? Then there's what part. So what do you want to change? Do you want to add privileges? Do you want to remove privileges or explicitly set them? And then which privileges should be affected? Read, write, execute. That's all we can specify there. We can also combine it. So we write just UG plus RW, which will mean that give user, owner, and the owning group permissions to read and write. But now, our cool thing is the numeric way. You're gonna find it pretty often, as it's mostly preferred, but it's a bit harder to read because it's where's the numeric of numbers. First number are user privileges, so the privileges for the owner. Second number are the group privileges, and for 3, it's others privileges. As you see here, for example, we have this 650, which will be just chmod 650 file.txt. This would mean that for the owner, we add read and write because 4 plus 2 equals 6. Then for the group, we have 4 plus 1, which equals to 5, which stands right here, which means 4 plus 1 read plus execute. And then we have 0, which means that other people on this file have no privileges. When we know how to do it and how to maybe use the ls command and change the privileges, let's maybe figure out the anatomy of it as well. First thing we see here are the privileges. We've discussed them really deeply before, so let's say, and by the way, coming back a little bit, here's the source I took it from. I'm gonna link in the description and probably in the comment below. I highly recommend checking out this article. It's really interesting. Coming back to ls results, first are privileges, we talked about them. Then there's a number of hard links on this machine. We're going to talk about them in the part where we have been using terminal. Then we have the owner specified here. Then the owner group. Here is the size of the file in bytes. Then when it was created. And this is just month, day, year. Month in this 3-letter format. And then the file name, the actual file name. That's what you're gonna see if you're gonna type in ls-l. But about all of that we discussed previously, so check it out. That's it for the theory for today. If there's going to be anything more, I'm gonna explain it to you while we run the lab. So see you in a second, and we're gonna type some commands into a shell. Cheers. Alright, now we are back in our Linux, so let's maybe keep this a bit shorter and start right away. First, we're gonna launch our terminal. As I told you before, I'm not going to focus too much on GUI and all the graphical interface, as it's kind of similar to Windows and pretty intuitive. So let's go with command line. First, to create a file, you'll use touch command. Touch. The syntax is pretty simple, just type in touch and then name of file. Let's name it notes.txt. Now when we list our home directory, we're gonna see that there was this new file notes.txt created. To edit it, we can do it in two ways. First, we can use echo command, which by default just displays something to our terminal, and we can pipe it. So just send it into notes.txt using this little arrow here. Click enter, and right now in notes.txt we have display. But this pipe here is going to do one thing. It's going to replace the whole content of the file with this one word. This is what is here. So to append something to the file, you can use the same thing, but right here, add another arrow. Just type in this way. We'll be having two of these in notes.txt. But running it like this is not the only choice. There's a vast amount of CLI text editors. Most popular are Vim and Nano. Let's open Nano, notes.txt. This way, as you see here, we can edit the file as if we are to be doing it in Notepad or Word. Notes. Then, to save it, we use Ctrl and O and type in Enter. This little thing here means Control. Ctrl X, we can exit. We're back to our terminal. It's also VI, is just Vim, notes.txt. Now we can do everything, but this requires a bit more of getting into it. Maybe next time we're gonna talk about it more, but now we should know it exists. This is the first question, how to exit Vim. You just type in .enq. Alright. When we know how to create files, how to edit them, now maybe we just don't want to always display them in text editor. To display a file, we can use cat utility, notes.txt, As you see here, it displayed to our terminal contents of a file. But files don't always fit into our command line. They can be really massive. How to work with these kind of files? We can use add and tails command. Let's maybe take slash etc slash password as our example, but what it is I'm gonna tell you. So type using head, we get in first 10 inserts there, the root name and all that. Then using tails, actually not tails, the password, we get bottom 10. Kinda cool, right? There's also a utility called res, where we can go down and search for all the things. Also, we can search for in the files using arrows, top and bottom, and type in dash q to exit. Alright, we know how to create files, edit them, and read them. Maybe we want to move them somewhere. To copy the file from one place to another, we use cp command. Let's copy our notes.txt into /temporary/notes.txt. Now it got copied, so if we want to find, well, let me just use a cat. As we know this, /tmp/notes.txt is here, it works there. It's right there, it works there. Very nice. But we don't always have to copy the files. Sometimes we just can move it. To do this, you can use mv command. Mv command, apart from moving files, can also be used to rename them. Syntax is basically the same. Here is the source and here is the destination. To rename this node, let's say we are tired of using txt and we want to add some more colors and some more advanced stuff to it, so we're going to change this extension here to markdown. We can just move contents from nodes.txt to nodes.markdown. And you see here, it's there, nodes.markdown. But we don't really have to move only one file. Let's say we have plenty of these type of nodes. Let's maybe create nodes.txt, nodes. What else can it be? .text, nodes, PDF. We have all these nodes here. Plenty of it. We can, for example, create ourselves a new directory. As before, make directory nodes. And then we can move all of these with one command to nodes. How? It's really simple. We can use a thing called wildcard. This is this little wildcard symbol. We start with move nodes, and then we input this wildcard, which means that it's going to match this expression to everything that has starts with nodes and has something in the end. As you see here, these 4 files follow the same pattern. There is nodes and something down out there, some extension. We're gonna move it to /, let's say this directory nodes / just nodes. We type in enter nodes dot. Yeah, we can move the directory to itself, but right now we have all the other nodes moved. Is it true? Yes, you see, nothing here is. We can go to nodes and list all. /a will just list everything with the hidden ones, and as you see here, all the nodes are right here. Alright, after moving and displaying, and now it's time to work with another type of files called binaries. For example, move, cp, and cd. These are all binaries, which I've told you before. It's just a program that allows us to do something. That's a binary called in Linux. To find out where the binary is located, let's say we want to know where cp is, we can use which command. It's going to tell us that, alright, when you type cp, you are referring to user/bin/cp. But what is this part of path and how the paths work? Go check out the last video. I talk about it much more in depth. Right now, That's how we can find binaries, but not normal files. There are two methods of it. One is simpler, but it's not everywhere. For example, in our Linux, right here, we don't have the binary called locate. Sometimes in some distros you're gonna find it. It works pretty simple. Just type in locate and the file name here, and it's gonna find you the exact path of it. But as you see here, it's not always possible. It's here, but a default Linux binary to locate files and directories is called bind. First, we specify where we want to search for it. Let's say dash, and then specify what do we look for. Let's say we would look for a file named notes.pdf. You see here, it's there in home. What are those notes? Notes.pdf. Cool, right? Then we know it's fine. Fine, we can also search for other directories. Just search one directory or whole file system or the current directory with this dot. That's whatever you need. And also, find command can frequently produce really a huge amount of gibberish. For example, when you search for something in slash in the root directory, it's going to tell you that plenty of process files are permission denied because it just can't read them because you're running it as normal user and not as root. So to eliminate, you can find in any other command that returns errors. You can after you find it, after this structure here, let's maybe copy this. Remember to copy files in terminal, use Ctrl-Shift-C, not Ctrl-C, because Ctrl-C, as you see, kills the current process. And then as well, Ctrl-Shift-V to paste there. Just need to add to //dev/null. This way, all the errors will be sent to /dev/null, which is just a void of links. So we're going to see them. Next object type that we have discussed was links. I think you remember when I told you about object types, there are directories, there are files, and there are links. There are two types of links. First is symlink and second is hardlink. Symlink stands for symbolic link. It's a file that acts as a shortcut or pointer to another file or directory. When you access symlink, you're redirected to the actual file or directory it points to. You can imagine it kind of like a signpost pointing to a specific house. The signpost isn't the house, it just directs you to where the site is located. For example, here you see this L means the symlink and it's face.icon. And it redirects us to face, which is here. Simple example. Symlink stores the path to the target file or directory, and when you open or interact with the symlink, the system follows this path here to the actual file. So, face. It can link to a file or directory located on a different file system or partition. That's a cool thing. And if the target is deleted, the symlink becomes broken. So if we would just delete this face, this symlink will be broken and just won't work. On the other hand, hardlink is a direct reference to the same physical data on this as another file. It essentially creates another name for the same file. You can think of it as just a house, and a hardlink as an extra door leading into the same house. So with the initial file, which is the main door, and some backdoor is a hardlink. It points to the same inode, which is the underlying data structure of the file system, as the original file. And because both these files share the same inode, when we delete the original file, the hardlink works just as fine. But it has some limitations because it works only on the same file system partition, and it cannot link to directories. While symlinks can link to some directories, hardlinks can't do that. Let's maybe make a new directory called links. We're gonna show it, see what it looks like. cd link, I know. We're going to create some file and make it original.txt. First thing we're gonna do is we're going to create two links. First, with link command. First will be a hard link, original.txt hardlink.hard.txt, and then I'm going to create the symbolic link. Link -s for symbolic, original.txt, symbolic.txt. Let me see here. Hard looks just like a normal file, and symbolic, the symbolic link, going to org. Then if we, hey, let's maybe cat hard.txt, it's going to show us contents of the original. Let's do the same with sim. Does the same thing. But right now, if we delete the original text with remove command, txt, you see here, this one became broken. There is no original txt, but hard works just as fine. And for tests, we try to sim. It just exists, but doesn't exist, like a Schrodinger's cat. All right. Now, also I've introduced you to another concept of deleting files. The last thing, which I want to talk about with just simple files, use rm to delete. We've seen this kind before last time, but that time we used it to delete directories. So remove takes plenty of parameters, but there are two most important ones. -r means recursive, so it deletes everything inside. It can delete a folder, a directory with exactly everything that's inside, and force, which is going to remove it forcefully. What else? Another one thing also we need to mention are environmental variables. These are variables stored by the system that can be accessed by processes. For example, if you have the preference in your terminal that you want it to be black, it needs to store it somewhere. That's where environmental variables come in handy. We can use command env to see them. It shows stuff like user, display all the colors, language, our working directory, our home directory. The most important thing, the variable right now, I want you to know is path. Because when we type in cp, for example, our system needs to find this binary to execute it. So it first says, all right, let's look in the current directory. So in link, is cp here? Is the binary cp here? No, I can't see it. All right, maybe it's in the path. So it goes, is in user local bin cp? No. Is cp in user/bin? Yes. All right, so for you to execute this binary, this cp, you need to address user/bin/cp. That's what path is for, to tell the system where binaries are located so we can execute them wherever we are. We can update, we can change it just like a normal environmental variable, just with our export. Then we can say with this $path, we can change it to, what's that, our home with our dots to our path variable. This way, you see here, the valid plus home with our dots slash. Oh, like this, sorry. Yes, so here there is no $, but here is very important because $sign means we are addressing the variable. Right now, if we use cat path, or not cat but echo path, sorry, you see here it's set. So if we had some binary in our home directory right now, it would search for it in home first. This is the most important one if you want to read, because every process has their own environmental variables. Often processes store their things like access tokens, API keys, some credentials, or whatever else can be stored in a process. To access it, we can use /process/PID, process ID, which is the number of the process. This is the ID of a process, different for every single one. / and then env. To access the process, the amount of variables of the current process, you use self symlink plus self env1. You see, you can use just like cat, and we see all the different environmental variables here. This is the first of the important quote-unquote files I want to cover. So if you want to just check out the variables, as I told you, you run this thing. Then there are a couple of more you should be aware of. First, we'll go to etc. directory, which stores very important files. As was mentioned before, it stores editable text configs. First file that we mentioned before will be /etc/passwd. This stores users, their shells, home directories, and basic information about them. For example, their user ID, groups ID, etc. Let's take root for example. It's username root, it's X. Then we have user ID, group ID, their home directory here, and their default shell. Back then, here or in some older versions, in this place of X, you could place user's hash. But right now, these hashes were moved to /etc/shadow. This file can be read only by root. You can see it /shadow. No, maybe not display, etc/shadow. You see, it just can be read and write by root. Everyone in the shadow group can read it, and no one else can. That's very important because, you know, you don't want anyone to see even though hashed passwords. But we still don't want anyone to see them. We're gonna see in a while when we reach another file, but now let's talk about something else. Another important file in this directory is /etc/host. It works as your local DNS server. So pretty much, if you'd go into the browser and type in Debian or localhost, it would say, all right, our user requests URL localhost, and we have it in our hosts, which means you need to send it to this IP address, which is a loopback, our home, our just home, just this machine is going to send it back to itself. Then there's also cat/motd, which stands for message of the day. Whenever you launch a new shell, or you log in, whenever you log in, this, for example, with SSH, this will pop out. You can change it and you can add there some personalized message or so. Then, next one is shells, etc/shells, and it stores all the valid shells that user can use. You can use bin/s, bin/bash, user bin shell, and all of that. The last thing I want to mention is /etc/sudoers. Those not readable by anyone else but root. And it stores all the information about who can do what in Linux. You can let's maybe switch to root right now so you can see all the files. su dash means switch user to root. As you remember, root password was learn linux 123, and it's clear with clear command. If we cat /etc/sudoers, you can see that all members of sudo group can execute all and all. Let's maybe add our user, so wizardos or whatever user you have called it, to this file so we don't have to switch to root always. To do it, we're going to use a special utility called vsudo /etc/sudoers. This way, if we type in something that would not, because I think this file can straight up break your system. If you mess up editing this file, this could mean that, alright, you can't run anything as an administrator and you'd probably need whole system reinstall to do so. That's why vsudo is in place. It works, it is a nano binary, but creates it a temporary sudoers file and tests if file contains no errors. If it contains, it just does not input, because if we just edit it with nano, we mess something up, goodbye to your Debian. Let's type in here the same wizard dots, all equals all. This way we have all the privileges just like root. More about them, about users' privileges, how to set them, how they work, about rules on how to set the privileges. We're gonna talk in some of the next videos. Let's now just save it and exit it. And coming back to Shadow, now we are root. So we can cat etc. Shadow. And you see here, for example, for Wizardos, it stores our password here. This is a hashed form. Hash is to keep it short. It's like a way to encrypt, but it's one way. Yeah, it's like one-way encryption. So if you have hash and you encrypt it one way, you cannot decrypt it otherwise. That's what hash is, and it's a safe way to store passwords. First 3 characters mean the hash type. Right here we have Y, which means this hash is in YesScript format, but this is not the only one. This password is stored in 3, let's say, how can I say it? Because this password itself has 3 parts. First is the ID of the hash, then we have the salt, and then password itself. What is salt? Salt is a bunch of random characters added to the beginning or the end of the password, so the hash becomes harder to crack. I don't want to go too deeply into how hash cracking works. I will probably make another video or short on it, so stay tuned and subscribe to my channel to hear me discussing how hash cracking works. But this salt makes our password much more secure. And this ID can be different. Y, as I told you, is for YesScript. If instead of Y there was 6, mean this is SHA 512 crypt. F5, it means it's SHA 256 crypt. 2Y means it's blowfish, just like 2A. And 1 means MD5. If there is a password stored in MD5 hash, you should probably change it to something much more important. Alright, etc. is done. Let's now go to another place called pv/procs. This way, here stores plenty of information apart from only our processes, which IDs can be seen here. Let's start with cat meminfo. So the absolute path would be /prod/meminfo. This displays all the information about memory usage. Total memory, free memory, available, cache, swap, inactive, blocked. Just typical IT stuff. Self, as I told you before, is a symbolic link to the process that the program that looks at it. So for example, if we went to self, so get us to the process ID of this shell right here. /stat displays all the statistics of the system. Process running, process blocked, CPU usage, etc. Then version, so /prod/version, shows information about Linux kernel. The same result can be seen using command uname -a. So be even a bit shorter. Then there's uptime, which contains 2 really weird numbers. First is a total number of seconds machine has been up, and second is total number of seconds machine has spent idle. There are plenty of more of this files in procs directory. I'm gonna link it in the description, a way where you can read all of that. That also stuff about uptime, version, and whatever is stored in proc if you're willing to learn about it. And let's put it this way, that is really about it. So thank you so much for watching. I hope you enjoyed this little tutorial. If you like what I'm doing here, leave a like, subscribe, and if you were more familiar with Linux, you will notice that I did not say too much about find, even though it's a very hard command. Let this be your homework for you to read about find command, so you can find all the different things this find can do, because you don't need to search by name, you can search by size, by file type, and whatever else you possibly think of. So check it out. You can reply to the comments, so other people don't have to look for it. And yeah, that's really about it. Leave a like, subscribe, and stay tuned, because the next video will come really soon. Cheers!